speaker is Kunal Bhattacharya. He's a platform engineer at PepsiCo and is also an open source contributor. His talk today is going to be about database change management, thousands of tables across multiple environments, and one Alembic to rule them all. This is going to be the last talk for this track. So make sure you give him a round of applause that he deserves. Yeah, let's welcome.
Hello. Am I audible? Hello everyone. Welcome to my session. Thank you for attending. And before we get into the session, can we have a big round of applause for all the organizers, volunteers, sponsors, this wonderful lady who has been doodling amazing summaries, and basically everyone who's made this event possible. So thank you everyone. I hope all of you had a fantastic PyCon, and all of you will be going back to your offices, to your homes, with a lot of key takeaways, and I hope to see many more of you in the upcoming PyCons as well. Brief introduction about myself. So I am a data platform engineer at PepsiCo. I have a decade of experience, a little over a decade of experience as an IT professional. And as you can see from the stickers on my laptop as well, I have a lot of them, which prove that I have been here for a while. I graduated as a civil engineer and then moved over to software and started liking started liking what I was doing, and then gradually I have also started dabbling my hands in open source right now. I contribute quite regularly to a PySpark package called Quinn. Before we delve into today's session and the agenda, quick show of hands. How many of you have worked with databases in production settings, be as a data engineer, application engineer? Okay, fair amount of people. So let's relive I'll help you relive a traumatic experience that most of you must have had. It's migration day, and as you are the DevOps guy, or you are the data engineer or the data platform engineer, you have sent across entire script that the migration folks have to execute before your application changes can go in. And they start executing the script, and whoops, something breaks. Now you're confused. What is breaking? I have logged everything. Well, turns out you missed an alter statement somewhere, and not to pile on the bad luck, but if you did not run it within a transaction, you suddenly don't even know how to roll back whatever got executed. Within a transaction, at least, unless and until you hit a commit, you can roll back everything. But without a transaction, now you don't know how to roll back, and it's a higher environment. So you cannot just undo systems. Small script, you can still manually do some changes. Now imagine 1500 lines of code, and the error happened on line number 489. You probably did changes to 11 tables by then. How do you get that back? So what are the usual suspects? We have faced this problem, but what causes this problem in the most number of cases? A developer forgets to check in a small change, like an alter statement, a quick alter statement that I had forgotten to check into my Git repository before I logged out on Friday. An accidental drop delete table, drop from table, drop table if exists, and it should not have had the if exists, so it dropped an existing table. Or for those who have worked on Snowflake, there's something called an imported privileges grant. So you passed an imported privileges grant because of which a lot of things were working, and you forgot to check that in, and now a lot of roles are not working, commands are not working. So these are some of the higher level suspects that usually cause these migration days to become nightmares very fast. And that is where we have the need for database change management. The words simply imply what it means. It means to basically manage the changes that are applied to a database. So drilling a little deeper, that just involves tracking and controlling the changes. In majority of the cases, those can be restricted to the DDLs and DMLs. DCLs can also be tracked, but there are far better tools out there like Terraform and OpenTofu. So better to control your DCLs via Terraform and just restrict database change management to be applied to DDL and DML upgrades. So, and how do we do that? DCM, database change management is just it's a methodology. It's a way of doing things. How do we actually do it on the ground? Alembic. So, Alembic is a fully open source database migrations tool written by the makers of SQL Alchemy. How many of us have heard the name of SQL Alchemy? Fantastic. So we know that it's been developed by some people who really know the business out there. What does it do? It provides an ACID compliant framework. It's open source, provides an ACID compliant ORM, I would add the word ORM as well, ACID and ORM compliant framework where migration scripts for the entire database can be constructed. You can construct the migration scripts, you can maintain them in GitHub. I'll show the demo in some time. And then they can be executed across multiple database environments. How does it help? It gives you single command upgrades and downgrades. None of the tracking 15,000 lines of code in a single file and sending over to the DevOps team and DevOps team going ahead and executing them and something goes wrong and going back to the developers. None of that. That entire cycle gets collapsed into just one single statement of upgrades and downgrades that can also be executed via CI processes. So the entire chain gets automated with adequate traceability and auditability. What are the use cases? So we can do, as I just mentioned, we can do the DB schema migrations, seamless database and schema upgrades and downgrades. Plug and play DB sync. What it means is you can easily, for all of you who have worked with production databases, if you face some issue in your lower environments, or maybe you face an issue in production and you need to debug it in your lower environments, right? You need to replicate the production into a lower environment before you can debug it, right? So you can easily recreate the production or staging database in your local environments as well. Test database changes pre-prod. You need to upgrade apply your changes on the pre-prod or the staging before your changes move into prod. So you can use Alembic to basically apply the migrations and upgrade your test or pre-prod, whatever you call it. And lastly, auditability, which I like to call it as Git for databases. So just how in Git you can maintain the entire life cycle of your code, including whatever changes went through it. You can track the life cycle of your database changes, including all DDLs and DMLs in the database via Alembic. Before moving on, I know most of you have the question, what makes it the most reliable? Why should I go with Alembic? I'm sure if you Google, you'll probably find a couple more companies or open source solutions which are also doing pretty similar tasks. Quick show of hands. Any one of you driving a Toyota around here? The red Toyota out there is for reliability. Okay. So I myself drive a Tata, by the way. So so back to it. So what makes Alembic the most reliable? So first of all, it's ORM and ACID compliant. ORM, the object relational mapping framework, basically helps portability across multiple databases. So if you maintain your codes, if your DDLs and DMLs in the ORM syntax, you can easily apply it in Postgres, tomorrow in Snowflake, and the day after tomorrow in Oracle. It can be easily ported without having to change the syntax. Trusted by Airflow and Snowflake. Snowflake, in its own documentation, they themselves mention Alembic as one of the solutions that can be used. And Airflow's metadata DB is synced with Alembic. And if you go to their Airflow's repository, you will find Alembic configuration setup. And I hope, how many of you have heard about either of Snowflake and Alembic over here? Snowflake or Airflow? Great. So we have proper industry projects that are set up on Alembic. There's an active open source community. And lastly, it's very easy to set up, easy to extend functionality depending on the needs for your teams. Before we jump further, everything sounds too good to be true. What are the trade-offs? There has to be a catch, right? Well, turns out there is. First of all, I'll come to this part later. First is the added maintenance. So all this while we have been, running your SQL scripts and all that, and you're done. You just give the script one time to your your platform team or your DevOps team, and they execute it, and you're done. Someone just saves that underscore DDMMYY, finished. Now you have an Alembic package that needs to be maintained. It needs to be updated every time you update your Python version. Need to preserve the state of the environment for Alembic, so there's an added maintenance. And the other thing is convenience versus auditability, right? Instead of just writing your SQL code and executing it on your database, now you have to run it via something called a revision file. But well, as I said, so everything in software engineering is a trade-off. So that bit of convenience that you sacrifice will come in handy when you are saved from the tortures of corrupting your database. Before moving further and trying to understand how else we can leverage the power of Alembic, we need to understand what are the key concepts to be able to work with it, right? So the first one is a migration environment. So this is kind of the foundation on which Alembic stands. It's the directory of scripts and migration files that you set up for the very first time you're initializing Alembic on your project, right? You just do an Alembic init, and it creates the scripts and migration files and the layout. You create it once, you maintain it forever. You don't have to come back to it over and over again until and unless you're changing something on your database setup, like you're maybe adding a new database or your credentials for your database are changing. Then comes your Alembic environment. Now, don't get confused here. So the migration environment is kind of the superset, and within that is the Alembic environment. So this has the environment.py file that configures the database connection and the target metadata. It sets the context for the Alembic execution. So what do I mean by that? You can connect with your database via username password, but rarely does that happen in a production system. You will have your private key files, your SSO single sign-ons. So a whole lot of security is done to secure the state of databases. So there's no one size fits all. So all of that connectivity, whether you have to decode your private key files or you have to enforce the single sign-on, you set it up from the environment.py script. Next comes the Alembic config, which is the alembic.ini config file, and this is where you set up your database URL. Where will the scripts live? The scripts which the migration scripts which you are generating, where will they get generated and stay throughout the life cycle, throughout your project life cycle? You define everything in the alembic.ini file, and I'll show all of these things in the demo. Then we have the migration script. So once you start, now that you have done the changes on the first three, you're ready to start using Alembic, and the first thing you do is basically create a migration script. It's super easy, just one command, Alembic migrations, Alembic revisions, and then some message, and it creates a boilerplate migration script which has an upgrade and a downgrade function set up, but it's not doing anything. We have to put our SQL code in there to make the seamless migrations possible, to basically apply the upgrade. Then comes the revision ID. The revision ID is a part of the migration script, and it basically tracks the hierarchy. So if we are applying 3 changes to the database, and if we want that hierarchy to be maintained, there has to be some way of maintaining the hierarchy, and that hierarchy is maintained via the revision ID. So every file has a revision ID of its own, and the down revision ID, which basically references to the previous file that got executed. And these are all maintained automatically by Alembic. You don't have to do anything other than just executing a single command to generate the migration file. Then comes the upgrade and downgrade function. That's also a part of the migration script that gets generated. Blank boilerplate function, as I've written there. and we have to populate our DDL and DML. So instead of running the create table command directly on your database, you just paste the same command inside the upgrade function. That's the only change you're doing here. And finally, you have the version table. So this basically preserves the state of your database. Within your database, it basically preserves the state of your Alembic revision, so that tomorrow when you are trying to upgrade your database again, your Alembic is going to reference this particular Alembic version table to understand where is your database at, and then it's going to upgrade from there. So it kind of gives the plane of reference. 7 distinct concepts that will arm you to work with Alembic. Now the question is, I've talked a lot about Alembic, but I started with database change management. So does Alembic actually solve the database change management problem? Let's jump into the demo. So the terminal is not terminal. Terminal is not coming. So basically, I'll just, okay, you can see clearly, right? So this is the basic nature of how my directory looks like. This is the migration environment that I've set up, and I've just done an Alembic init. So it gave me, ignored the pip file and pipfile.log. It just gave me the Alembic folder, and within that I have a readme file. I have the environment.py file, and I have the versions, and I have the alembic.ini. So these are the important files. You can ignore the readme and the script.py.marco file, though you don't need to even touch those files, right? So before making changes, we'll just check what is the, we'll just check the other 2 files, which is environment.py, which is the Alembic environment, and the alembic.ini config file. What do those contain, right? So the alembic.ini, this is where we are setting up the database URL. If you can see, I have a Postgres database. I've given the database schema name, the port, and the database name, and the username password, right? And everything else, all of this is boilerplate. This is where the script location, this is equal to Alembic. This is also auto set, so you don't have to change anything here. And that's about it. This just setting your database connections here in this line number 63 is going to enable you to connect to your database from your local, assuming your database is set up on your local itself. This is just for a rapid prototyping, right? Now, how is the connection being set up? That is being set up via the environment.py file, right? So here you can see that we are setting up the pool, and then we are using the context manager, connectable.context to basically set up the connection, right? So if you have any key files to be decoded, and you have a separate way of authenticating yourself to a database as it happens in our company systems, you'll have to set it up inside this. You'll basically have to override this run migrations online function within the environment.py file. So this is good for our prototyping, for our demo, right? So here's what I'm going to do. I'm just going to show you the state of the database before starting with. So this is my Postgres database, and if you see here, Okay, let me ignore that. So let's see whether the table exists or not. Uh, jerry.public.account. So the table does not exist, and the customers table we can just check where it does not exist as well. And the Alembic version table that I talked about, well, it's blank right now, right? So let's just apply the changes to this database and see how things take effect, right? And the amount of effort that's involved. So the command is going to be very simple. It's just going to be, it's a pipenv run Alembic revision. So the main part of the command is just Alembic revision, and then I'm passing a message, which is create accounts table. You can just pass any message. It's as I said, it's simply like git commit, right? And I press enter. And it created a file. Let's look at what file got created. So this is the file that got created. Okay. So here, if you see this file, there are some important tricks here, important concepts here. First is the revision. So this is the revision ID of the file. This is what will track how how Alembic is going to execute the statements one by one, right? And then you have the down revision, which is set to none. That just indicates that this is the first file in the entire flow that's going to happen going forward, right? So this is the first revision file that's going to get executed, right? And then you can ignore the branch labels and depends on. Those are more advanced concepts that are beyond the scope of this talk. And then you have the upgrade and the downgrade functions, which are currently set to pass, right? And these upgrade and downgrades are what we are going to basically apply, right? So for the purpose of this session, we're going to generate a few more of these revision files. So I'm going to generate a customers table as well. There's a customer table revision file that got created. None of these changes are applied to the database at this stage yet. Okay. And then I'm going to do some alteration on my accounts table as well. So alter. And finally, I'm going to do some data inserts. So I am going to insert into my accounts table. Right. So at this point, I should have 4 revision files. If you can see here in the versions, you have 4 revision files. There's no way to track which file came first here. But if you start looking at the files within the versions, that's where you're going to be able to connect the dots. So if you remember, after the accounts table, we created the revision file for the customers table, create customer table. So let's look at the customer table file. Okay. So here, if you see, the down revision is populated to the previous file. So the whatever was the revision ID of the create accounts table file, the ones ending with 4259, is the down revision for the next revision file, and this particular file has its own revision ID. So now hope you can understand now how these particular revisions are getting maintained, how the genealogy is getting maintained, right? And similarly, this will happen for the other files as well. And now I'll just quickly show you how the upgrade and downgrade part. So what I'm going to do is I have the upgrade and downgrade set with me. So I'm just going to copy them one by one, right? So I've created the accounts table, and I've created for the customers table, I also have the upgrades and downgrades. And then I have the alter table. So for the alter, I'm just going to populate the upgrade and downgrade for the alter table. And finally, I have the insert. And for this one, I'm just going to insert whatever I have to basically do the insert. So I'm just populating the upgrade and downgrade functions, right? And yeah, now what I'm going to do is I am going to run the upgrade. But before I run the upgrade command, I think I should clear the board. Yes. So the upgrade command is very simple again. Pip and run Alembic upgrade head. And before I run the head, I'm just going to do the --- SQL, which will basically show me what all SQLs are going to get executed. And now that I know what SQLs are going to get executed, I can just run the upgrade head. And you can see that all the upgrades have been executed. It says here running upgrade, and you can see the flow as well. Let's just check at the database level whether everything got executed or not. So let's just see what is the version, whether the Alembic version has some value. It was previously empty. Yep, it has some value. And let's look at the accounts table. And now you have the accounts table with the data populated inside there. And if you see the customers table as well, the table exists. Previously, it was not, right? So we created the accounts table, we created customers table, we modified the accounts table, we inserted data into the account table, right? And all of this is now tracked with my Alembic setup, right? So I know what you're thinking. You're probably thinking, okay, but this is not exactly a very friendly syntax to maintain. I mean, which data engineer likes to do all of this op.bulk insert and this kind of a syntax to basically do some inserts into tables. This is not friendly, right? So we are much more comfortable with our insert into basically our ANSI SQL standards, right? So we can do the same thing via ANSI SQL as well. So I'm just going to show it here. So if I just remove everything that's there, and I'm going to save this. So I made the changes, and in the insert into table, now you can see that insert into account is there. So now you can see one important thing is that how easy it is to downgrade the whole thing. So if I want to remove these whole changes, I can just remove the downgrade. I can just use the downgrade command, and it basically just wipes off everything. And if I take a look at the database, let's run the same customers table command once again, and the table is gone. So all data is wiped out. And now that I have made the changes to that to the script to basically incorporate the ANSI SQL, now what I'm going to do is I'm going to just run the upgrade once more. The upgrades have been done, and just to validate, let's check the accounts table once more. Yeah, the customers table once more is back, right? So as you can see, this is how Alembic basically fits into the whole thing. You now have a complete track of all the commands that you're executing on the database, and yeah, so you can because it's open source, you can easily port it across like extend its functionality and use it across multiple database. With that in mind, thank you everyone for attending my talk. And if you have any questions, feel free to get in touch with me. Right?
Okay. Maybe we'll take one small question. We'll have an additional 1 minute for this. Any questions? Yeah. One small question.
So we can see a lot of version files, right? Do we need to maintain this into the GitHub as well? Like too many versions files going to be generated by the Alembic?
Yes. So that is the power that Alembic gives you. So
one point of time, if you have 100 tables and then too many transactions happening, that will be huge to maintain, right?
Yeah, but for you, that's the beauty of Alembic. So for you, it's just you're just running the Alembic upgrade or Alembic downgrade command. Even if it's 2,000 tables. In production setups, I've worked with Alembic setups where we have like 2,500 odd migration scripts, right? So for any developer, he's just concerned with only the change he's pushing in. You're not maintaining that, right? And nobody's going to, as long as you're not playing around with the revision IDs, everything will be intact, right? So if you are a new developer, you just come in, or it's a new database, you just come in and run Alembic upgrade. So it just runs everything.
Thank you.
For any more questions, just get a hold of him in the hallway track.